It's a little bit in the future, too much buzzwords and hype. I want to bring the hype a little bit more concrete and show you some things that are already available, some privacy-based networks that are launching mainnet even this year. So a little bit to inspire you to actually build privacy-first apps. My name is Ramiro. I'm part of Cryo Labs. We develop Obscura. Obscura, it's a layer that we put on top or under privacy-based networks that allows developers to connect easier to these new privacy-based networks that are coming up very soon. So this is a little bit of what's ahead for this conversation. I want to dive a little bit on privacy, CK cryptography, all the buzzwords. I want to focus on privacy networks, specifically on Aleo, tell you a little bit what's going on there. But let's jump right in. So quick things, you've already been talking about this for the whole weekend pretty much. What is privacy? Why do we care about it? A little bit the why and the what. So of course, the why is a little bit what the previous talk was about. We would like to be more proactive, disclosing what we want. And the what, I think, is something that is not entirely clear in terms of the solutions that we want to build. You have, of course, Ethereum that is completely open. All the transactions, all the addresses, the volumes, everything is transparent there. So that's a little bit of an issue. In the ideal world, and this is also an invitation for you to think a little about what you want to have as a private statement versus a public statement on a decentralized system. So you have things like transaction details, the metadata. There are certain metadata that in aggregation can be very dangerous, but it's certain metadata that, by the fact being public, allows for compliance. So we're going to dive a little bit deeper into this. And feel free to stop me if you want to really zoom into one of these things. But I think this is the hottest thing. Well, for us, it's been for a couple of years already, but I think is breaking more into the common knowledge and the public and developers that are coming from Web3 and even from Web2, because CK literally enables privacy. But in which way? I'm going to spend a little bit of time here just to showcase a little bit the flow of a CK proof and how it works. This is depicting specifically a snark. So we're going to go left to right. And you may have already seen this if you already dove a little bit into CK. But I think it's important to highlight a little bit what's coming on the flows that maybe you as a developer, as a solutions architect, you want to start thinking about these terms of the identities that are involved in actually structuring things like that. So you have a prover, you have a verifier. The general thing that you want to understand about zero knowledge is that the prover tries to state that the prover knows X such that Y is f of X. What does this mean? The prover on the other side needs to be convinced of that. So usually you have a protocol that is interactive. So provers creates a proof, send the proof to the verifier. The verifiers offer a challenge in the same of a mathematical equation that needs to be solved. And then this is an interaction that usually happens at a statistical level. The great breakthrough was having an oracle in between that allows you to kind of skip that interaction to make it literally very succinct, because of the size of the proofs can be very small, but also non-interactive, which means that there is no interaction that needs to happen between the prover and the verifier. What does this mean? It means that you can effectively implement these two subsystems completely independently, and you can work asynchronously. And that's a little bit of what the new privacy-based networks are trying to leverage. In this example, to put it in more concrete terms, if I'm the prover, maybe in the use case of you're an adult trying to buy alcohol online, the very first thing that somebody will ask you is, okay, are you actually an adult? And can you prove that? Under normal circumstances, you will need to reveal maybe your date of birth, something about your ID, your name, the issuer of that ID. So in the spirit of keeping as much privacy as you can about yourself, you're probably not inclined to share all those things. So in this example, I know X. X will be the claim that you are above 18. It's just a Boolean. Yes, no. Are you adult? In some countries, you can consider to be adult beyond 18, 21. The X, in this case, is the witness. The witness, you will find in the literature, if you brave enough to dive into the white papers, you will see that the witness is literally the data that you care about generating a proof of. So the witness, it can be private, and that's kind of the most juicy aspect of that, but it can also be public. In our case, our witness or data will be your ID, the day that you were born, for example. And what you're trying to compute is a proof that you're claiming that the output is Y, that yes, Y should be true, right? You are an adult. And that's what a little bit of this exchange is. What you see on top is the, salud, is the idea exchange that in reality, in implemented protocols, this doesn't really happen because now, based on the current SNARK systems or any other modern proving system, you kind of skip this, and the prover is smart enough to just generate a proof that already contains challenges. So there's no need to go back and forward a couple of times. The proof itself contains the randomness needed that both the prover and the verifier shares in order that the verifiers can immediately start challenging the proof itself. So I know this is a little bit of a mouthful, but I think it's interesting to have this in context for the conversation that follows. And just to demystify a little bit, because probably what you hear when you talk about zero knowledge is the idea of a snark. And if you're brave enough, you delve a little bit deeper and you found Starks and Plonks and Sonic and all these things that you can read in the literature. I think CK snarks are the entry level for zero knowledge. And this is one of the things that if you want to dive deeper and start building privacy-based applications, it's good for you to understand these very principles. And this is why it's so rich, so important, and so useful. The CK part is because the proof doesn't carry any information about the witness, the data that you're trying to prove. So the proof only contains yes, no, and it doesn't contain any information in this example about my age or the ID or anything behind that. It is succinct because literally the size in bytes. And you have different flavors or CK proof. Some of them are bigger, some of them are smaller. There's a little bit of a trade-off between the size of the proof, the time of generating that proof, the time that it takes to verify that proof, and different systems or different solutions choose different CK proof systems based on these constraints and trade-off. And depending on what you need, maybe you need a very short proof because when you're trying to optimize is the space on the storage of that proof. Maybe you need a different system that the proof can be a bit larger, but it allows you to build a faster proof, or the computation to build a proof is a little bit less expensive. These are the kind of things that you will consider if you dive deeper into architecting a zero-knowledge system. It is not interactive because of what I just described. We skip basically all this thanks to an intermediate random oracle. And this is part of an initial setup that the prover and the verifier can share a secret that doesn't even need to be secret based on the new CK proofs like Plonk, for example. This also, the last argument is a little bit confusing. It's the argument of knowledge. What does it mean? But it's very rooted in the mathematics of it, in the polynomial structure that this proof actually has. But without getting too deep into the mathematics, it basically says that the proof actually carries an actual knowledge that this is it. And for this, you need to trust me. We're not going to dive deeper into this, but if you want to find me afterwards, we can go deeper into the mathematics of how you kind of actually encode arguments in proofs based on polynomials. So I'll leave you with that image. This is a little bit what I was talking before. There's a plethora of CK systems. Many different teams, very brilliant people have been working on this for the past decade or so. The very first paper on zero knowledge was, I think, published in 1985. And it depicted the idea of an interactive proof that the challenger and the verifier need to go very much back and forward. Since then, I think Roth 16 came in the 2016. And ever since, you've seen the ecosystem exploding, basically, mostly at a research level. And this took quite a long time to be picked on the engineering side. So a lot of brave teams, before I jump into the teams, I will share, of course, the slides with you. But this is a little bit of what I was talking about before, the different constraints and the trade-offs that you will have in different proofs. And I will show you first the proof, and later I will show you the systems, the different systems that are using these proofs. So then you can make your own decision based on the solution that you want to build. What's the system that suits better your own needs? And that's a little bit of as software engineers, where we need to try to understand what are the constraints that we have and what are the possibilities that we have to actually build a real life solution. Coming back to the usage, and I feel CK has been a buzzword, not for the wrong reasons, but mainly because of scalability, right? You see Polygon, well, how many other rollups, you know better than me. I hear rollups, 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 rollups. None of that is using zero knowledge for privacy. And since this is a conference for privacy, we're gonna skip all the rollups because I feel also it's been more in the public eye, so you probably already know quite a bit of how to use zero knowledge for rollups, which is basically aggregating proof of transactions and bundling transactions into bigger bits so you can spend less in the finality of where it goes actually to something like Ethereum in a block. This is where I want to focus on, the CK usage for privacy. We, as Obscura and Crya, we've been working on this side of the spectrum for a couple of years now, and we had the chance to work with many different teams that are actually focusing on all these topics. And you can see that this is pretty wide, like range of solutions that you can build. And later in this talk, I will focus a little bit more on the gaming side, just to give you a more concrete example of the type of systems that you can start architecting with this technology. But what we see that is coming even this year and in the coming years is solutions on the DeFi area, like an actual decentralized exchange that can keep the privacy of their users. And it's not a trivial thing to build, but it's one of the very first things that you're going to see being built and launched even this year. The other big area, of course, is identity management. So think about an encrypted verifiable credential. The idea of, hey, you have your ID, your passport. Every time that you go somewhere that you need to prove something about yourself, you're disclosing your full data. What if you don't need to disclose your full data? What if you can just generate a zero knowledge proof that makes the claim that you were born in this country, or you were not born in this country, or you're above certain age? And these are the kind of solutions that we're going to start seeing in the coming years, hopefully. Governance, DAOs, right? How do you make decisions together? How do you reach a consensus as humans, as part of a group, as part of a squad? Well, messaging, there are some applications on CK mailing, or CK email. If you Google CK email, it's a really good project. Machine learning. The CKML ecosystem is kind of exploding right now. It is a big buzzword, but also the research in terms of the mathematics on how to merge matrix manipulations, matrix multiplications with the polynomial structure of information that you have in zero knowledge proof. There is a lot of teams that are starting to bridge that gap, so I'm actually very excited about that. I don't think we're going to have like production-ready zero knowledge machine learning applications tomorrow, but it's definitely one of the most exciting things in terms of the complexity of the mathematics behind that. And ultimately gaming, specifically gaming on, if you're more like coming from a gaming theory perspective, the incomplete information games. Things like involve two parties and sharing some secrets, poker, or anything involving a fog of war, basically. I want to introduce you to a little bit of what we've been working with and partnering up from Crya and Obscura. These are the layer 1s and layer 2s that are using zero knowledge specifically for privacy. So Polygon is a little bit of a X case because they do have their CK virtual machine and they're using zero knowledge for scalability, but also for privacy. I'm not going to talk too much about Polygon because you know Polygon. What I want to focus in these three. These are layer 1s that are launching. Well, in the case of Aleo, it's launching this year. Mainnet is already testing this on. You can go and have a blast and try to build something cool, like some of the things that we showed before. Mina, they released last week on their testnet Berkeley. They released the programmability aspect of their chain. So also you can immediately go and try to build something on Mina. Dusk is also out there. It's focusing more on the DeFi aspect of things. Very strong team. And then we have the L2s, like Aztec works a little bit on top of Ethereum, and same with Manta. I'm going to skip Polygon. I would like to focus a little bit more on Aleo, but if you're curious about any of this, please find me later and we can talk more about it. You can also see that some of them have different trade-offs. They use different proving systems, and they also use specific languages, because when you try to encode logic that can generate zero-knowledge proofs, you need to go through a process of arithmetization. So you need to translate this logic into a mathematical circuit that eventually can be formally proven. Different teams have found different solutions to actually go around that. So you can see like Aleo using Leo, Aztec is using Noir, Mina is actually using TypeScript on top of a library that they develop. So depending on your preference of language as a developer, you can even use Rust sometimes. And you have teams like Risk Zero, that is like a zero knowledge virtual machine where you can just Rust and that will generate proofs. So it's pretty powerful. I'm seeing the time, and I think I'm going to skip some of it because I also want to have some time for you to ask some questions. But this is a little bit Aleo. Aleo stands for Autonomous Ledger Execution Off-Chain. Howard Wood, the founder of Aleo, published a paper, I think it was 2019. It was called Sexy, Zero Knowledge Execution. The idea behind Aleo is what you see here, is the evolution of programmability versus privacy. And you can, of course, everything starts with Bitcoin. But as you can see, like if you remember Zcash, that was trying to add some privacy on top of that, but Zcash still didn't have programmability. Ethereum came to be, and here we all are. But Ethereum, of course, is super transparent. Everything is public. Aleo was trying to merge the idea of a UTXO model in terms of data structure that Bitcoin had, and the idea of an account model that Ethereum had. So Aleo came up with the record model, where you can still have kind of the best of both worlds, where you can still store your transactions, but also you can add private state on-chain with specific logic. This is a little bit of the evolution of that timeline. Coming back on the things that you can actually build with this technology today, with a caveat, some of these things may be slow, some of these things may be expensive, and some of these things may break. But this is what we're all trying to understand: what's the best way to build, what can be built, and what's the most cost-efficient and secure way to build these kind of things. So this is more like a suggestion to all of you to try to think about what are the kind of privacy-based apps that can be built today, just to inspire you of like all these areas have something that you can immediately solve using zero knowledge without circumventing all the craziness that you need for adding privacy to this thing. So what I mentioned a little bit before, identity. Well, you have verifiable credentials. You have different ways of authentication without revealing some aspect of who you are. KYC, if you're working more on the enterprise side of things, knowing your customer is a very big deal, and a lot of companies are trying to figure out how to do that without over-disclosing too much information. Gaming, probably my favorite topic. Incomplete information games, because now you have verifiable random functions that can actually be verified because they just can generate a proof, and in a later stage, in a asynchronous way, you can eventually prove something and verify something. That kind of allows things like, I don't know if you're familiar with the actual Dark Forest. That was one of the very first on-chain games put together in Ethereum. You could rebuild your Dark Forest using zero knowledge, and you probably reduce the code size by like 1x, like 10x or something. Seeing the time, I'm going to skim through this, but come to me later. We can talk about all these use cases, but this is just to give you an idea of the things that you can build today. And to zoom in a little bit of one of the things, this was a project, ScoreSage was a project for a hackathon that the Obscura team did, I think it was last year in Paris. This is just a glance to give you an idea of the kind of things that you can start architecting with zero knowledge. And you start seeing like different entities where you will have like a verifier in your architecture map. And you can start decentralizing and having things asynchronously. And I'm going to skim through this. Come to me later if you want to dive deeper into leaderboards. The great thing about leaderboards, if you make it private, is that you can get the best of both worlds. If you're a player of a rank-based game, you want to play poker, you don't care about the betting, but you care to be top one. Usually what happens for on-chain games is that what's going to be revealed in a leaderboard is going to be your address. If I give you a prize, and that prize goes to your address, you have 1 million Ethereum in that address, you're going to become a target because that's public. Everyone knows that now you have like that amount of value in that address. With these kind of setups, what you can have is instead of revealing your address, you reveal your public username. And in the back, we can privately store on-chain the relationship between your username and your address. So you get the best of both worlds. You get to brag about that you're actually the best because you can actually verify, because you will have a zero-knowledge proof that you are who you say you are. And you can keep kind of your valuables because that's not exposed to the rest of the network. Sneak peek, if you want to write this in Leo, for example, this is a little bit how the code look like. You can scan this. This is a repository on GitHub. It's open source. Knock yourself out. It's a tiny repository. This is a little bit the same, but implemented in a different language. This is using Aztec Noir. So you can have different implementations for the same kind of problem, and you can judge what makes more sense to your own use case. And I want to leave some space for a question. I know that I'm on the mark.
Yeah, we've probably got time for one quick question. Yeah, nice.
Thank you very much. Thank you very much for that talk. The question I had was about the bit where you said that everybody's using different languages when they're using zero knowledges for privacy. And then my question is maybe like you could touch on that again as to why that's happening. That sounded very interesting. But more importantly, where do you think that goes, as in how that converges? Because normally you have like languages that go out of fashion, and then the more popular ones, they have like this network effect that mean that unless we can start implementing zero knowledge proofs maybe with Solidity, it makes it more and more restrictive and prohibitive. What are your thoughts on all these different languages?
Two things. What I would like to happen is that everything converges to Rust. So nobody needs to learn any other language. What I see in reality is completely the opposite, that you're going to start seeing domain-specific languages, DSLs, like Aleo, Noir, like something else, just because teams had a lot of trouble encoding logic into zero-knowledge arithmetic circuits that can generate proofs. That's kind of the most active area of research, how you can do that in an optimal way. And that's why entire companies are being built to develop zero-knowledge virtual machines. So it's going to take some time. If you learn Rust, you're good, because a lot of companies are also trying to kind of converge into Rust. There are a few virtual machines that now can compile Rust code and generate proofs out of that. That's a little bit the point. Like those domain-specific languages are there to easily encode the semantics that you will use on a zero-knowledge kind of architecture, thinking about the prover and the verifier and the witness. I hope that answers your question.
Thank you very much. That was really good.
Well, thanks a lot. Please connect to us on Discord. Here we can have all the questions. Thanks a lot.